Let's look at how to solve radical equations. And I don't mean radical as in totally cool, even though they are. I mean radical as in roots, like square roots and cube roots, etc. So before we solve equations, we need to review a few things about radicals. First, I want to remind you radicals, how to write radicals as powers. So if you have x or anything to the 1/2 power, the fraction in the exponent tells us two things. The denominator tells us what root we're looking at. So this means a second root of x, the second root of x. And the numerator tells us what power we're raising that to. So the second root of x raised to the first power. And the second root of x is used so frequently, we don't ever write this index of 2. We simply call it the square root of x without writing an index. And to the first power, we don't need to write that either. So if you raise something to the 1/2 power, it's equivalent to the square root of that thing. If we take something to the 1/3 power, it's the same idea. It's a cube root of x to the first power, so it's just a cube root of x. And finally, like if we have x to the 4/5 power, well, that's a fifth root of x, but now that is raised to the 4th power. And I want to caution you about writing your roots. This is called, this middle guy is called a cube root of x. It's not the third square root. It's not a square root at all. It's a cube root of x. And you don't want to write it like this, because this means 3 times the square root of x. So be cautious in how you read these and how you write them. Another concept I want to review before we get into solving are important exponent property, an important exponent property that we'll utilize here. And let's review basically for a minute. If I have x squared to the 3rd power, well, that means x squared times itself 3 times. And if you still can't see what this simplifies to, well, x squared is the same thing as x times x. So if x times x times itself 3 times, which now when it's all expanded out, you can say, oh, well, that's just x multiplied by itself 6 times, which more simply we can write as x to the 6th power. And what I'm wanting to remind you here is when you raise a power to a power, you multiply those together. And you can see why this turns into 3 groups of 2 x's, giving us 6 x's. So what's pretty cool about this, though, is when you have rational exponents, fractional exponents, like x to the 2/3 power, which we know is some kind of cube root. But if we cube that, well, that turns into x to the multiply 2/3 times 3 power. And 2/3 times 3 is 2. So this turns into just x squared. Pretty cool, right? And one of the things we're really going to take advantage of is if you've got x to like the 3/7 power and you want to undo that, you would simply raise it to the reciprocal power 7/3, because 3/7 times 7/3 is 1. And we don't have to write 1 as an exponent. So you can raise a power to its reciprocal to cancel it out, which is a cool property. Let's start solving some radical equations. Okay, let's try to solve the square root of 2x minus 3 equals 9. And the approach we're going to take to solving these equations is undoing the root. So the way to undo a root is to raise it to a power. The inverse of square rooting is squaring. So what I'm going to do is take both sides of this equation to the 2nd power. And now my square undoes the square root. So I get 2x minus 3 equals 81. So I can add 3 and then divide by 2 to see that I get 42. Now, because square roots have an issue, or even roots have an issue, like if you want to take a square root of a negative, you're going to get imaginary answers. And there's no imaginary numbers in this equation. So you always want to check your answer. So I'm going to write it out on this first example. 2 times 42 is 84 minus 3. Well, the square root of 84 minus 3 is the square root of 81, which is 9, and that equals 9, so we're good. This guy does check. When you have an even root, it's important to remember to check your answer. Now, this next one's going to look more complex, but I'm doing that to show you that they're still pretty basic to solve. Let's look at negative 5 plus 4 times the square root of x plus 3 equals 3. Now, you've got to be really careful here. What a lot of people will do, and I see it all the time, is they'll say, oh, there's a square root that I need to get rid of. And how do you get rid of a square root again? Well, you square it. The problem is you have to square just the square root. And so a lot of people will get this half right. They'll say, oh, I need to square it, and get so excited. They'll say, okay, I'm going to square the left side and square the right side. That's not going to work out for you. Because if you square the left side properly, if you square anything properly, you're going to multiply it by itself. So you're going to have negative 5 plus 4 square roots of x plus 3 times another negative 5 plus 4 square roots of x plus 3, because this is what it means to square. And you're going to have to distribute all of this, and it's going to become a big old mess. Don't do that. Employ the general strategy that when you look at an equation, if there's something that's different in the equation than everything else, and your variable's there, then get that guy by himself. So isolate this guy first, and then you can get rid of it. So I'll call this isolate and undo. Get it by itself, and then you can get rid of it. So the way to get it by itself is to add the 5 over. So we get 4 square roots of x plus 3 equals 8. And then to get rid of this multiplication by the 4, divide both sides by 4 to get the square root of x plus 3 equals 2. Now we can get rid of the square root by squaring both sides to get x plus 3 equals 4, which means that x equals 1. And because it was a square root, I would plug this back in, and I would see that this does, in fact, check. Okay? So make sure, get your root by itself before you try to undo it. Let's solve the equation. The fourth root of 3x minus 1 minus 2 equals 1. And I'm going to take my same advice. I want this strange looking guy by himself first. So I'm going to add 2 to both sides. And just as a side note, the way we read this is the fourth root of 3x minus 1. We don't call it the fourth square root. This is not a square root, it's a fourth root. If I add the 2 over, I get 3. Now I can get rid of my fourth root by raising it to the fourth power. And if I do it on the left side, I have to do it on the right side as well. So I get 3x minus 1 equals 81. Add the 1 over and divide by 3. And if I plug that back into the original equation, I get a true statement, so it checks. Okay, let's look at negative x plus 8 to the 1/2 power minus x plus 2 equals 0. We want to solve this. There's a couple ways to do it. You could say, all right, well, this guy looks kind of strange, so let's get him by himself and then figure out how to undo it. You could also say, oh yeah, a 1/2 power is a square root of negative x plus 8. So you could rewrite the whole thing by calling this a square root and then get the square root by itself and undo it. So since we've been working with square roots, I'm not going to do it on this one because I figure you can do that. I'll leave it as is and work on isolating this guy and talk about how to undo it. So to get this guy by himself, I need to add x and subtract 2 over to the right. And now to undo a 1/2 power, to make that 1/2 power go away, I'm going to raise both sides to the second power, because 1/2 times, let me back up. Remember when you raise a power to a power, you multiply the exponents? So what I'm trying to do is turn this 1/2 into a 1. And the way to do that is to multiply by 2 or raise to the second power. But if I do it on the left side, I have to do it on the right side as well. Notice on the left side that what's inside the red brackets here could be written as the square root of negative x plus 8. And how do you undo a square root? You square it. So we're still squaring it, but we're thinking of squaring it to cancel the exponent of 1/2 and turn it into a 1. So it has the same effect either way. I'm showing you both so you can start to decide what you like better. So on the left side, I get negative x plus 8 to the first power. So I don't need to write that anymore. On the right side, I get x minus 2 squared. So x minus 2 times x minus 2, which gives me x squared minus 2x minus another 2x, so minus 4x plus 4. And now the weird looking guy, the 1/2 power, is gone. This is a quadratic equation. And to solve a quadratic equation, we want to get all of our terms together on one side. So I'm going to take my negative x and plus 8 and move them over to make it positive x and negative 8. So if I add x to negative 4x, I get minus 3x. And subtract 8 from 4, I get minus 4. And then it's a matter of factoring or using a quadratic formula. This guy factors pretty easily as x plus 1 times x minus 4. And finally, well, x plus 1 could be 0 to make the whole thing 0. Or x minus 4 could be 0 to make the whole thing 0. So we get two solutions, x equals negative 1 or 4. But what we have to realize is our original equation was a square root of some kind, because this denominator in the exponent was a 2. It's an even root. That means we need to check these answers. So if I plug in negative 1 for x, negative 1 is positive 1, plus 8 is 9. The square root of 9 is 3. Minus negative 1 is 4, plus 2 is not 0. So negative 1 does not check. If we plug in 4, negative 4 plus 8 is 4. The square root of 4 is 2. 2 minus 4 is negative 2. Negative 2 plus 2 is 0. So positive 4 checks. Okay, hope that made sense. Okay, let's do another. Can't have too many examples, right? How about x minus 4 to the 1/3 plus 6 equals 2. And again, you can think about this as a cube root. You could rewrite it as a cube root and then solve it that way. I'm going to leave it as a 1/3 power just so we get more experience with that. So I'm going to get this guy by himself first by subtracting 6 over, which leaves me a negative 4. And then to undo a 1/3 power, I need to raise it to the third power. because the exponents will multiply here, and 1/3 times 3 is 1. But if I do that on the left side, I have to do it on the right side as well. So on the left side, I just get x minus 4 to the first power, and on the right side, I get negative 64. Adding 4 over, I get negative 60. Now, the original problem was a cube root problem, an odd root problem. We don't need to check our answer for odd roots. So we learn to appreciate odd roots. Let's say we want to solve the equation negative 2 times the square root of 4x plus 5 equals 2x. And the way I'm going to do this is, as we have in the past, I'm going to get my square root by itself by dividing both sides by negative 2, which leaves the square root of 4x plus 5. If I divide 2x by negative 2, I just get negative x, because 2 divided by negative 2 is negative 1. Now to get rid of my square root, I'm going to square it. If I do it on the left side, I have to do it on the right side. Well, negative x squared, if you're not sure, remember, squaring something means multiplying it by itself. Negative x times negative x, well, negative times a negative is a positive, and x times x is x squared. So negative x squaring it just gives us x squared. And again, we have a quadratic equation, so I need to get all my terms on one side. So I'm going to move everything to the right, giving me x squared minus 4x minus 5. And again, this factors nicely as x plus 1 times x minus 5. So x could be negative 1 to make x plus 1 0, or x could be positive 5 to make x minus 5 0. And because this is a square root, I need to check my answers again. So if I plug in negative 1 for x, I get negative 4 plus 5, which is 1. The square root of 1 is 1, times negative 2 is negative 2. So on the left side, I get negative 2. On the right side, 2 times negative 1 is negative 2. So this guy checks because that's true. Let's plug in 5 for x. 4 times 5 is 20, plus 5 is 25. The square root of 25 is 5, times negative 2 is negative 10. On the right side, we get 2 times 5, which is 10, and of course that's not true, so x can't be 5. So our only solution is x equals negative 1. Let's solve one last equation using one of the exponent properties we learned. Let's say we want to solve 3x to the 5/3 power equals 32. And, you know, the weird looking thing, the 3x to the 5/3 is already by itself. So I just need to think about how to undo the 5/3 power. And I could rewrite this as some sort of cube root. That'd be totally fine. But I'm going to take advantage of what we learned. If I want 3x to be raised to the first power, so we don't have to write a power at all, then I need to take 3x to the 5/3 and raise it to the reciprocal power 3/5. And if I do it on the left side, I have to keep it balanced by doing the same exact thing to the right side. And understand that 32 to the 3/5 power is just a number. Okay, so we can look at that more. But over here, 5/3 times 3/5 is 1. So we just get 3x on the left side. On the right side, we could put this into a calculator, but what would be the fun in that? Instead, let's see if we can do it by hand. So we got a denominator 5, so that's a 5th root of 32. And then a numerator of 3, so that means to the 3rd power. So we get 3x equals, well, the 5th root of 32 means what multiplies by itself 5 times to be 32. And I've got some experience with roots, so I know that the 5th root of 32 is 2, because 2 times 2 times 2 times 2 times 2 is 32. So fifth root of 32 is 2, but I still have to cube that. I have to multiply it by itself 3 times. 2 times 2 times 2 is 8. And now we can divide both sides by 3 to see that x equals 8 thirds. And because the original problem had a denominator of 3, this is an odd root. We don't need to check our answer. Okay, so lots of varied examples with solving radical equations. Some you have to check, some you don't. Sometimes you have to use factoring, sometimes you don't. Sometimes you use reciprocal exponents to solve. Sometimes you undo the root. But I hope it all makes sense. I hope there are plenty of examples for you. Get some practice on your own and see how it goes.